Hey there, what's up guys? This is Bert again. Today I'm gonna explain you how electricity works. Okay, starting by atomistic. Atomistic is just a science in chemistry, that a subject in chemistry, right? That studies how atoms works, right? The behavior of atoms in nature. Okay, so you already know what an atom is, right? We can consider for this class the minor part of the matter. Okay, so of course we have a lot of other particles, but this is not the case now for now because we are just studying electrons. Okay, so electricity, the word electricity means electrons. Okay, so electrons, right? So this is why electricity, right? So as you know, let's review some concepts about atoms. So every atom has a nucleus, and inside that nucleus we have protons, protons plus neutrons. Okay, protons and neutrons, right? So protons and neutrons are together on a nucleus. Okay, and around this we have an orbit. Okay, an orbit that is composed by electrons. Okay, so one electron is a particle that orbit the nucleus of an atom. Okay, so in this case we have this draw here. Okay, I'm sorry for this messy this messy draw here, guys. Okay, so but basically it's something like that. Okay, so we have the nucleus here with protons and neutrons, and surrounding it we have electrons. So then electricity works with these rounding electrons. Okay, because it's the moving particle of the atom. Okay, so you can't move protons or neutrons. You also can, but uh, you have to put so much energy to do that. Okay, and to move an electron we have to put less, very 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 less energy to move this electron from that orbit here to a more external orbit here, right? So then you put less energy, less effort to make this position change. Okay, so and this movement that electron does through atoms. So we have, let's say we have a cable. Okay, a simple copper cable, right? Let me draw here a simple copper cable. Imagine this rectangle here is just a copper cable. Okay, so this is a copper cable. I will explain later on another videos about some materials that compose cables. Okay, like aluminum, copper, and gold, even gold, right? Fiber and so on. Okay, but let's focus on copper. That's the most common material used to make these conductors. Okay, conductors. Yeah, so then copper has just one free electron. Free electron is the electron or those electrons that are in the most external, okay, it's better, the most external orbit, the most external orbit. Okay, so then you can easily put it off. Okay, you can easily move from this atom to another atom. Okay, so of course we have billions and billions of copper atoms here. Okay, so each material has a specific atom. Okay, so for the copper we say it's Cu, right, the name of the atom, copper atom. Of course, in one copper wire we have billions and billions of atoms. Okay, as you can see here, and we we don't we don't consider these atoms here. We are just looking for electrons. Okay, let's focus just on electrons. Okay, so then we have billions and billions of electrons here. So that is uh, that is the object of study of electricity, the electron. Okay, so then when we have a movement here, we say that we have a current flow. Okay, so what is an electrical current? Electrical current means a flow of electrons passing through the wire. Okay, so then when we have this current flow passing through the wire, we must have a electrical current, okay, or a current flow through these electrons. Okay, so remember that the charge, the value of the or better, the signal of discharge of an electron is negative. Okay, so it's minus, it's negative. Okay, so when you work with electricity, we are working with negative charges. Okay, so and why does my battery shows plus and minus, positive and negative uh, signs? Because it's a convention, guys, it's just a convention. Okay, so then when we have a battery, let me explain better here. Let's imagine we have 90 volts battery here, so then we have the plus and then we have the minus here, so it's positive side and negative side. We will explain it better in another video. Okay, so this side has the most positive parts of the side. Remember that these two sides can't touch each other because it will generate a short circuit. Okay, we will explain it better too. Okay, so but why do I say that is a convention? Because electron has a negative sign. Okay, so and why this part is positive? Okay, so we say that it's positive because it's full of electrons, full of electrons. I will denotate electron as E minus, like this. Okay, so it's full of electrons. Okay, and this side, despite of this side that is empty of electrons. Okay, so no electrons here on this side. And imagine that electricity works passing electrons through a wire cable or a circuit. Okay, and the destination of those electrons is just the other side. Okay, so you have to begin here to end here. Okay, so then this is the path of the electrons. Okay, so when these sides come empty, the other side will come fully. Okay, but we won't have a potential difference, okay, that makes this electricity happen. Okay, so what is the potential difference? The difference of potential. Okay, it basically means voltage. Okay, as we also known as voltage. Okay, denoted by V. Okay, voltage. Sure. So we have a battery here with 9 volts. So this 9 volts is just the difference of potential. Okay, so the difference between these two boards here are 9 volts. Okay, so when I pick some tool like a multimeter, okay, so you pick a multimeter and put the voltage mode, you see that will mark 9 volts, okay, if the battery was fully charged. But uh, when you are using this battery, of course it will discharge. Okay, so it reach a moment when this battery will get fully empty. Okay, and then of course this difference of potential will be uh, under 9 voltage, something around 7, 6, or even 0, fully 0 volts between these 2 points, because all of the electrons at the positive sides come up to the negative side, and then we don't have more difference of potential. Okay, so then we can't use this battery anymore. um, of course, if you have a battery that can be charged. Okay, so I'm considering this is a 9 voltage battery that is usually not be charged anymore. Okay, you just can use it one time. Okay, and the the duration of this battery can be up to 1 week. Okay, it depends on your equipment. If you are using to turn on a radio or something different on a remote controller, okay, it can be be used for a long time. Okay, so when we talking about this battery, guys, again, when we transpose those electrons that were on the positive side to the negative side, we don't have the potential difference anymore. So then if we have the electrons yet, but on the negative side despite of the positive side, we don't have the the potential difference, right? So now those electrons are on a neutral state. Okay, neutral state. So we can't change this polarity here. We can't change minus to plus and vice versa. Okay, we can't change this because these electrons here are on a neutral state. Okay, it has already been neutralized. Okay, from a charge, a load that we call a load. Okay, it can be a radio, can be a cell phone, can be a smartphone, a smartwatch, and whatever equipment you can turn on with a 9 volts battery. Okay, so that's that's how electricity works basically, right? We have uh, this potential difference, right? It can be something like that. You have a water tank. Okay, let me try to draw a water tank here. Okay, so then we have a simple water tank here. You put water here. Okay, imagine this is water. You put water here, and then we have another water tank here, and your idea is to put this water on this tank, from this tank 1 to this tank 2. So what do you do in this case? You pick a pipe here, okay, just a pipe, and then the water flows to the tank 2 without any effort. Okay, you just put the pipe here, and if the tank 2 is a little bit distant from in height, right, distant in height from the tank 1, the water flows, right? So it's okay, everyone can understand this idea. But and what about if you pick a tank, the same water tank, tank 1, with fully of water here, and you pick the same pipe, and then you put another tank here, the tank 2, and now you have to to get this water here from tank 1 to tank 2. So what do you do in this case? So for now we need a pump, right? We need a pump because you have to uh, you have to work with gravity. Okay guys, because gravity is pulling down every time. Okay, you have a force pulling down, that is gravity. So then you have to win this gravity, okay, to put this water flows through this pipe to the tank 2 from the tank 1. Okay, so then you have to put an effort here. Okay, an effort with a pump here. Okay, to put this water from tank 1 to tank 2. Okay, so it not flows like this one, okay, naturally, right? So and then we also can consider tank 1 and tank 2 on the same height. Okay, it's a height h and the same height h. Okay, and then you put a pipe between these two tanks, right, water tanks. So then it's fully completed. And so imagine, let's try another abstraction exercise here. Imagine you are feeding this tank 2 with water, so it's not fully yet, okay, and this one is empty, totally empty. So what do you think about, what do you think, which one will be fully first? Okay, guys, this idea is is not too easy to understand, because when we are feeding this tank here, so this tank won't be fully until the other tank, the tank 2, uh, be fully too. Okay, why? Because we are connecting at the same, we can call a breakpoint here, because water will flow until this mark here, and then it starts to flow to this tank here. Okay, so this time when water reaches this point, it will start to fill in this tank 2 until it gets the same mark here. So then it will start uh, to fill the same time. Okay, can you understand it? So it will start to fill up the tank 1. So then when it reaches this break point, okay, it will start to fill the tank 2, and then they when they are at the same point, they will start to fill uh, both tanks simultaneously, right? And then I can consider that these two tanks will be filled up at the same time. Okay, so you can count when this tank will be filled, this one will be filled too. Okay, at the same time you can consider. So in this case, back into electricity, this case we won't have any potential difference. Potential difference here is zero because we don't have this water uh, flowing through these tanks, because you can consider this difference of potential as the height. So the height here is zero. Okay, the difference between the height is zero because the two the, these two tanks here are on the same height. Okay, so it's no potential difference. Okay, you got it right. In this case, we we also have a potential difference. We can consider as a negative potential difference. Okay, negative potential difference. Okay, because if I try to move the water from the tank 2 to the tank 1, I can consider this idea because uh, you can easily put a pipe here and then water flows into the tank 1 easily, naturally. Okay, because we also have this potential difference. Okay, but it's negative. It's flowing from the tank 2 to the tank 1 and not vice versa. Okay, and not the opposite. Okay, so as we discussed before here, from tank 1 to tank 2. Okay, so that's the idea behind how basically electricity works. Okay guys, so thank you very much and see you next time. Thank you very much for watching, right? See you soon.